In this video, we're going to learn about piecewise functions, and we'll also just learn to work with them a lot, how to graph them, how to take a graph of them and evaluate them properly. So when we talk about piecewise functions, what we mean are functions that have different formulas for different x values, or a graph that looks completely different for different x values. So here's an example of one here. So what this is saying is that the function looks like 2x minus 1 as long as x is less than or equal to 1. But if x is bigger than 1, it looks completely different. It looks like x squared. So when I'm asked to evaluate something like f of negative 3, I have to decide which one of these intervals it's in. But of course, negative 3 is in the interval where x is less than or equal to 1. So in that case, I use the 2x minus 1 formula to answer the question. So we would say f of negative 3 is negative 7. If they ask me to find f of 1, okay, well this is right where it breaks, but of course we're going to include it with the less than or equal to symbol, right? So I'm still using the formula 2x minus 1. But then when I jump down here to find f of 4, okay, now 4 is greater than 1, so now I'm down here, so now I'm going to use the x squared part of the formula. So a piecewise function just simply has different rules for different intervals. All right, so let's look at how we go about graphing these things. I'm going to try to give you some different strategies in order to do this. Let me just say at the outset, though, it is very important that you are accurate, especially at the transition points. Okay, so as I look at this piecewise function, I'll see there's a transition at negative 1 and there's a transition at 1. I'm going to want to be really accurate in those places, right? So there's a few things you can do that can kind of help you along the way in graphing these. Here's one strategy that I think is helpful. With your pencil, what I want you to do is find the transition x values and lightly make a vertical line. And I'll do it in yellow, just kind of indicate really light. Lightly make a vertical line at those x values. The reason this is nice is because visually then you're able to see that to the left of this yellow line I should have one function. In between these two yellow lines I should have a completely different looking function, and then to the right of the yellow line I should have a completely different looking function. So there's where your three different functions are actually going to go. So that's one thing that can help. Another thing is making sure that you have your basic toolkit functions memorized. So remember y equals x squared, y equals x cubed, y equals x. Those were all toolkit functions. Those are things that from standard 1, we just want to have those in our brains. So if you don't kind of have the basics of each of those graphs in your mind already, it would be a good time to go back and study that just a little bit more. All right, so let's start with the y equals x squared here. Okay, we know that that's what we want over here to the left of negative 1. Okay, so y equals x squared should be happening in this region. So like I said, it's really important that we're accurate at x equals negative 1. So what I would suggest is make a little table here. So when x is negative 1, we know that y is negative 1 squared, which is 1. So I know that right here, I want to put a dot at negative 1, 1. But because notice that there's a strict inequality here, it's not less than or equal to, I'm going to put an open circle right there. And then I know I want to go left of this, so you know you might plug in negative 2, which would give you 4. Okay? And at this point, here's where it's really important to remember what y equals x squared looks like. Remember, on a normal graph, y equals x squared looks like this. So what we're seeing is we're just seeing this part of it right here, right? So as I make this, in my mind, I should be kind of thinking of doing this, right? Making that the bottom valley of that y equals x squared, and then just kind of continuing on with that. All right. So that takes care of that first part. So now let's think about y equals x cubed, which is going to be in here. All right. So if you know your y equals x cubed graph really well, you would remember it's got this general shape to it. And then you might even remember exactly what the values are at negative 1, 0, and 1. And if you can remember those, that's the very best. But if you forgot them, right, you can just make a little table. So negative 1 cubed is still negative 1, right? So that means I'm down here at negative 1, and since I'm including negative 1, I put a solid circle there. And then of course 0 cubed is 0, so I'm at 0, 0. And then 1 cubed is 1. All right. Oh, and that last one I kind of screwed up there, right? Let me get my eraser. I shouldn't be putting a solid circle, right? I should be putting an open circle because we are not including 1. And then this is where it's really important to remember that y equals x cubed looks like this. So I'm not just going to cut straight through, right? I'm going to do this kind of snake thing, this, we kind of call it like a little cubic jog, in order to connect up these points. And then lastly, y equals x. Well, if it's y equals x, we understand that whatever the x value is, that's your y. So when x is 1, y is 1. So we actually end up filling that circle in. When x is 2, y is 2. When x is 3, y is 3. So there's our function. Now, graphing piecewise functions can be pretty tricky. So one thing to always check on when you've finished your graph is make sure that it passes the vertical line test. So if you ever draw a vertical line and it hits the graph twice, you know something's wrong, because these things still have to be functions, and we learned how all functions must pass the vertical line test. So that's a quick way to see if there's something that needs to be fixed, pretty urgently. All right, and then of course we can answer questions based on this, right? So let's evaluate f of negative 1. So I go over to x equals negative 1, and you have your eyes are drawn to these 2 points, but of course you're going to go down to the one that's solid, right? So f of negative 1 is equal to negative 1. And in part B, f of 1, well, this one is also at the transition, but they happen to agree anyway, so that's just going to equal 1. And then one more down here, it asks us to solve f of x equals 4. Okay, so remember that's asking us what are the x values when y is equal to 4. Let's go back up here. All right, so we just find 4 on the y value, and you can see that x can be negative 2, but going over here, x can also be 4. So I give solutions of x equals negative 2 and x equals 4. All right, so now that we've gone through one together, I really encourage you to try example 3 on your own before you check out my solution to it. So go ahead and pause and give it a try. All right, so now that you're back, let's go ahead and work this out. So again, this is a totally optional step here. I've just found that it's kind of a nice tool for students. Go ahead and at the transition x values, make a vertical line. So at x equals -4 and x equals 2. Okay, so now in my head I have it really delineated. Now up here, when we say g of x is equal to 4, right, remember that's just y equals 4, which hopefully remember is just a horizontal line where the y value is always 4. So we want that to be the case from -4 and lower. So I'm going to go up to y equals 4. It's a strict inequality here, so I'm going to put an open circle and then I'm going to go this way with it. So I know what that looks like. Now the absolute value of x, remember that y equals the absolute value of x looks like this, right? It's a v. All right? And the bottom of that v happens when x is equal to 0. All right, so in other words, what we know is we can definitely put a point here, and then when it's positive, we just have y equals x, so it's going to look like that. And sorry, looking ahead, this should be a strict inequality, so that should be an open circle. And then over here, when x is -1, the absolute value is 1. Absolute value of -2 is 2, and so on. And we want to fill that in because we're including it here. So now it looks like that. And then lastly, we have 4 minus x. Okay. So this one, 4 minus x might not be a bad idea to make a table. Okay. So you could absolutely do it this way, where you start by putting in x equals 2, and saying 4 minus 2 is 2, and x equals 3, 4 minus 3 is 1. And so you get this, and then you kind of get the picture, right? You know where to go from there because it's just going to be a line. One other thing you might have done is you might have said, hey, I know how to graph this, right? This is a line with a y-intercept of 4 and a slope of -1. So some of you may have done this. Some of you may have said, okay, well, I could go up to 4 and then down 1 over 1, down 1 over 1, and so on. And that's fine. It's just that what you got to realize is, you can go ahead and draw that line in there. That's okay. But you got to understand that this part of the line is not allowed, right? Because this is only supposed to take place when x is greater than or equal to 2. So another strategy besides graphing points is just to graph the entire function and then come back with an eraser and erase all the parts that you don't want. Okay, so that's just a different strategy that you might decide to use. But either way, make sure that it passes the vertical line test everywhere. All right, so there's that part. And it does, it's a function everywhere, so I'm feeling pretty good about what I've drawn there. Now there will be times where you'll be asked to give a formula for a piecewise function. All right, so in this case, there are 3 different parts to this graph. So as I make the formula for it, I know I'm going to have 3 different sections here. So over here on the leftmost part, I can see I'm equal to 3. So y equals 3 is the formula. So I put f of x equals 3. But when should f of x equal 3? Right? It should equal 3 between -5 and -2. we don't want to include -5, but we do want to include -2, right? So we put a less than or equal to on the -2. Down here, this is y equals -1. So we put a -1 here, and we want that between -2 and 1. But you can see we don't want to include -2 for this part, and we do want to include 1 because there's a solid circle there. And then lastly, here we're up at y equals 4. So it's 4 for x is greater than 1, but is less than or equal to 5. All right, so this one here would be a good one to kind of try on your own. And remember, to do these ones where you have to come up with a formula effectively, you kind of have to remember those toolkit functions we talked about. All right, so once you've tried that, let's go ahead and create this thing. So we've got two different parts here. So that's not very good. Two different parts, so we're going to want two different formulas. So we might think for a second, okay, what graph is this? So remember, this one is part of the y equals 1 over x graph. Remember, y equals 1 over x is the one that has this look to it. So it's 1 over x. Well, where is it 1 over x? Well, this arrow continues on this way, right? So that means it just goes off to -infinity, and it goes until, well, we continue to get closer and closer to the y-axis. So we're getting closer and closer to x equals 0, but we never actually get there. So what we would say is that it's 1 over x when x is less than 0. And then this, okay, when I go over 1, I go up 1. When I go over 2, I go up 4. That looks like it's a y equals x squared graph. And this time, I'm allowed to be at 0, so I say x is greater than or equal to 0. All right, before we get going here on example 6, I noticed I have a typo here that needs to get corrected first. So please do scratch out that and put 0 is less than or equal to x is less than 4. Just had a mistake there. All right, now with that corrected, if you haven't been doing it so far, I really want you to do it on this one, is to go ahead and try this on your own before you look at my solution to it. All right, so try it on your own first. All right, so now that you've tried it on your own, let's put this thing together and see if we're correct about it. So first off, I'm going to put my vertical lines here at the transition x values. Try to make it a little easier on myself. All right, and let's see here. There's the 3 transition places. All right, so first off, let's take the cube root of x. You know, that one's one that maybe you don't have just stored in your mind right at the moment. So remember, what we do want to do though is be accurate at the transition point. So let's look at -1. What happens with the cube root of x at -1? Well, remember, we're looking for a number that if I multiply it times itself gives me -1. Well, -1 will do that, right? -1 times -1 times -1 is -1. So I know that that's the point I want, but because it's a strict inequality, we're going to put an open circle right there. Now I need one over here somewhere that I can do, and so I wouldn't just pick any old x value here. I want you to think about what's the next nice type of cube root that you get. Well, it would be a number that if you multiplied it by itself would give you what's inside of here. Well, the number 8 does that, right? If you put -8 in there, then the number -2 times itself gives you -8. So that tells me that if I go in the x value, -8, and down 2, then that would be a point on the graph as well. And then you might remember, right, that kind of has this general shape to it. So that's going to indicate that we want to do something like this. And I got a little bit too shallow there, sorry. So there we go. Okay. All right, so now let's take a look at the next one here. So we've got y equals x squared. All right, so again, transitions are important. So let's figure out what happens at -1 and 0. Well, when you square -1, you get 1. When you square 0, you get 0. So you get a point here and a point here, and I'm doing an open circle there because there's a strict inequality on that. But don't just lazily draw a line here. Remember that y equals x squared is a parabola. So this point 0, 0 is the bottom of that parabola, so kind of make sure that that's really indicated there. So it looks like that. All right, and then how about the square root of x? All right, so when x is equal to 0, the square root of 0 is 0, so I get to fill in that point at 0, 0. Taking my other transition x value, square root of 4 is 2, so when I go over 4, I go up 2, and I'm going to have an open circle there, because that's a strict inequality. And then it might be nice to have something in the middle, so another nice square root in the middle is when x equals 1. The square root of 1 is 1. So we get that picture right there. And then lastly, for y equals x minus 2, when x is 2 at that transition, or excuse me, when x is 4, not 2, excuse me. When x is 4, 4 minus 2 is 2, so we're at over 4 up 2, so I get to fill that in. Right, when x is 5, 5 minus 2 is 3. Right, so you get the picture now, right? It's going to look just like that.